January 11th, 2010, and the lesson is, where do... I'm not going there. Where do imaginary...
You know, that's what I want to do when I grow up. I want to do that when I get to the children.
That would be amazing. Where do imaginary numbers come from? Where do imaginary numbers come from? Okay, guys, focus up here on this. Sort of. Now, here's the deal. Tomorrow we're going to start learning how to manipulate something called imaginary numbers, and also called complex numbers. The reason why they're interesting is they seem to be impossible. We're not going to be able in this course to get to much of what they're used for, but they're used every day in certain fields like electrical engineering. Also, they used to be used in ship hull designs. I'll get into some reasons for that at the end. Here is the question that we're going to try to answer. If you're asking yourself, what is the square root of 4? Okay? Remember, this is a question where you're looking for one factor of 4 that you can multiply by itself and get 4. And what is that factor? 2. 2. What is the other possibility? Negative 2.
Could you just do plus or minus?
You can just do plus or minus, yes. Now, the reason why this works is because you can take the factor of 2, you can multiply 2 by 2 and get 4. I'll stop trying to make it sound fancy. Or you can multiply negative 2 times negative 2 and also get positive 4. Okay? The question is, what do you do if you have the square root of negative 4? It doesn't work is the short answer, and it's the answer that will work, that will carry you through most real-life applications. If you're doing carpentry, if you're doing basic engineering, mechanical engineering in particular, if you're doing, well, in mechanical engineering, you could wind up with trouble with this as well. Most things you do, and certainly counting change at the McDonald's, you will not ever need to wonder why this is or isn't true or what the problem is. The short answer is, it seems to work this way because if you look at these two choices, these seem like the only possibilities. It doesn't seem like there's any way to multiply the same number by itself and get negative 4. That's because you guys have been taking something for granted for a while. How long have you heard negative times a negative is a positive?
Since 7th grade. Yeah, I remember learning it in 7th grade.
You remember learning it in 7th grade? Sarah says, Brian says for a while. You guys ever ask yourself why that would really be true?
I never did.
I thought about it.
Okay, I'm glad. I did ask. I asked all of my teachers from the 8th grade on up, and I never got a straight answer. Yes?
Don't negatives cancel themselves.
That's more like a mnemonic. That's more like something to help you remember. But that's not really a why would they.
They always told me that the two positive numbers, when they get into a relationship, it's a positive relationship because they work together. And the two negative numbers are negative numbers, so they get along. So
I thought
positive.
Wow.
Okay, well that's not really a very good formal. And that really wouldn't hold up in like a formal college class of a proof. The canceling out is also a good way to remember it, but it really doesn't get to the question. And this gets to another thing, what are negative numbers? For real. Quite good enough. Close. Okay, here's the deal. In or around 1600, negative numbers were a very controversial topic in math. What could they possibly mean in the real world? We didn't have submarines, so we weren't going below sea level. Sea level hadn't really been defined yet. Temperature, no one had agreed on a single scale for temperature. So what would below 0 meant? They hadn't defined freezing or boiling yet as numbers. So they didn't have a temperature scale. People didn't have credit card debt. People didn't have bank accounts that went into overdraft. So what would you have used negative numbers for? So they really didn't talk about them much. And there were, when people started to find uses for them, there were a couple of different ideas on how to represent them. Yes?
They didn't talk about them, or they didn't need them?
Mathematicians, they didn't need them, is probably the best way to put it. Mathematicians talked about them. No, not really. Not in any way that everybody agreed on and said, this is a negative number and this is how it worked. A couple people had ideas. And the most popular idea was the negative number. Put a minus sign in front of it, treat it like subtraction. It means go left on the number line, and two negatives make a positive. That was the most popular one. But the second most popular one is where this idea comes from. Okay? And the second most popular idea was that they would use direction instead of negative. So they had a number line. They had 0 in the middle. And remember, this was an idea instead of negative numbers. So all numbers on this number line are positive. But they're represented by two ideas. It's kind of a two-dimensional way to think about them, okay? If this is the number 2, this was actually represented like a coordinate point, and it would be 2, 0 degrees. 2 represents the distance. 0 degrees represents that it's a 0-degree angle going to the right. Okay? Now think a minute orientation-wise. If going to the right is 0 degrees, what would going to the left be? How many degrees? There's no negatives in this construct. Okay. 0 degrees. 90 degrees.
Oh, right.
How many degrees?
180.
180 degrees. If you turn all the way around and go the other direction, you have turned 180 degrees. Correct? Does that make sense?
Wow.
Okay. So this guy, I think his name was Wallace, worked on this a lot. He didn't say -2. He said 2, 0 degrees, and then over here where -2 would be is 2, 180 degrees. 0 degrees is that way, 180 degrees is that way. Okay? Now from here, he came up with some rules, and he had to see if his rules worked. I mean, some things work, like a negative times a negative equaling a positive. That always struck me as being a little bit arbitrary. It sounded like something somebody made up. Other things don't in math. For example, if I hold up 2 fingers, then I hold up 2 fingers. How many fingers am I holding up? 4. So 2 plus 2 really seems to equal 4. And in order for us all to agree that's true, all we have to agree on is that the word for this is 2, and the word for this is 2, and the word for this is 4. Okay? This one, I can't hold up fingers and count. Okay? Why would a negative times a negative equal a positive? I can't count negatives on my toes. I'm not going to cut off limbs to try and prove a point. So, what do? Well, this is what this guy, who I think his name was Wallace, came up with. He's got positives being 0 degrees, negatives being 180 degrees. And he came up with rules, and he had to make sure that the rules he came up with fit what he knew. 2 plus 2 had to keep equaling 4. 5 minus 3 had to equal 2. Okay? So here were his rules. Addition. Addition would simply be move the given...
Do you have to write this? Because we know what
No, you don't have to write this part.
No.
Move the given... You can if you want to. If you want a history of number thought. Move the given number of units in the 0 degree direction. In the 0... Yes, you hopefully do know what addition is. Move the given number of units in the 0 degree direction. Okay? So what is 2, 0 degrees plus 5, 0 degrees going to equal?
7, 0.
7, 0 degrees, because you have to indicate you're still over to the right. That's like your plus sign. Okay? You start at the point you're given. You move more units in the same direction. Subtraction. Movement in the 180 degree direction.
You want to know on subtraction?
Yes. All right, whatever will make it consistent. Okay, subtraction, movement in the 180 degree direction. Okay, so what is... Actually, I don't think I need a number line for this. I hope I will draw it if I do, though. What is 5, 0 degrees plus 3, 180 degrees? What's that going to be in this system?
2, 0 degrees.
7, 180.
Oh my god.
No.
8, 180.
Oh, it'd be 8. Yeah.
Okay, this is the same. In our method, this would be 5 plus -3. And what does that equal?
2.
Positive 2. So Phil was right the first time. This would be 2, 0 degrees.
Wait, how do you know? How do you know it's a negative?
Because of the 180 degrees tells me that it's the 3 that's over here on the number line on the left side.
What if they didn't have negatives? Wouldn't they just add?
No, because when he presented this way of thinking about it, he presented that this was 3 units to the left of 0.